Oh, perfect. Thank you so much, Karen. Appreciate it. And thank you everyone for taking the time to join us today. Looking forward to the discussion. I think this is, as Karen mentioned, a topic of interest for a lot of people, regardless of what your background may be. The exposure to whether it may be funding or just drive within your local communities, building up climate resiliency strategies is very much at the forefront of thought for many of us. And on that note, the goal of today's presentation is to dive a little bit deeper into that, and more importantly, speak to how geospatial fits into that mix. What are those problems? And something that is really important to me is how that data is being communicated and how we're effectively sharing information in a way that people that may not necessarily have a technical background, your general constituents, the general public, would be able to absorb and understand. And to me, that is the power of geospatial data. And that's where, if we're all doing our jobs correctly, we can create a pretty compelling narrative. So Justin, do you want to introduce yourself briefly? Justin's going to be helping me out on the back end through this presentation, but he's also my primary point of contact as it relates to this work. So I'll let him briefly introduce himself, and then I'll kick things off myself.
Perfect. Thank you, Brandon. Yeah, so as Brandon mentioned, I'm Justin Proctor. I'm on the business development team here at Ecopia. I focus on the tax side of things, and more specifically, stormwater utility fees for municipalities. So I'll pass it back to Brandon.
Thanks, Justin. So Justin's going to be the one navigating your questions, fielding them, and helping to keep me on time, because I do know everyone is just a lunch and learn, and we don't want to go over the allotted time here. My name is Brandon Pallin. I'm the Senior Director for Public Sector at Ecopia. My primary roles are leading the charge as it relates to leveraging geospatial data within the public sector. So I oversee our work on the federal, state, and municipal side. And a lot of that ties into our larger scale programs in terms of our data development on national scales, whether it's work that we do with NOAA, the National Oceanic and Atmospheric Administration, in terms of their digital coast programs, or all the way working with individual states on the respective data development as it relates to geospatial information. And with that, I'm here today to kind of talk to you guys a little bit more about our work in this space, and hopefully address any questions or points that you guys may have on climate resiliency. But before I talk about those initiatives, for those of you that don't know Ecopia, I felt that it would merit a bit of a brief introduction to the company as well. So Ecopia is a geospatial data services company. Ultimately, we are an artificial intelligence company, but what I like to think of us as is more that geospatial data creator. AI is how we do the data creation, but ultimately our mission is to maintain the accuracy of quality of products just on a much larger scale. From where we started to where we are today has definitely been an adventure. So relatively speaking, the company is pretty young. It's only about 10 years old. But when you think about the space in terms of artificial intelligence, deep learning, even cloud computing, all of those elements didn't really exist 10 years ago. So we are very much at the forefront of the industry. And with that, we scaled our solutions and products, starting off with a very basic building footprint structure and product, all the way through to where we are today, which is effectively providing high resolution geospatial products, all the way down to planimetric level detail solutions that are empowering clients across over 100 countries around the world. So a very exciting narrative. But today, what I'm really going to focus on is the US nationwide land cover data and how that data is important to developing climate resiliency strategies. In terms of who we work with, ultimately, we've positioned ourselves where we're looking at data as not a service-based solution, but a product-based solution. We want to really see this data become a commodity in the market and something that's more highly adopted, used across agencies, across private and public sector. And essentially what we're bringing to the table is a concept of high resolution data that historically would not have been feasible to create at large scales that can now be integrated into workflows seamlessly. And you can see our network of clients here is everything from federal down through private sector, insurance, telecommunications, and even civil engineering and planning firms. So quite the wide variety of groups, but I like to show this because I think it does a pretty good job of articulating the value of the work that we're doing and that intrinsic value that's bringing to these organizations. So I like to show this slide because I think it puts things in perspective in terms of the work that we have done. And I also like to show this slide because even just a basic statistic in terms of building footprints tells a pretty unique narrative. So what you're seeing here is actually the building footprints that we extracted in Australia, Sub-Saharan Africa, and the United States. And ultimately, although this is just one figure of data and it's a piece of information we're going to talk about here, it really enables someone even who doesn't know what geospatial data is, or someone from the industry, to understand the power of information. It enables you to understand where people are, and it enables communities to understand resource allocation. And if anything, it makes something in terms of a big data set being, for the US, 172 million building footprints into something that's really understandable and concrete. And with that, the last piece I'm going to say is just in terms of our land cover data creation. So just this year, we completed the first 3D nationwide land cover map, a product that's being integrated into workflows across the country, and one that has really been critical for a lot of our clients, especially those that are looking in terms of having a foundational truth with geospatial data to integrate for climate resiliency strategies, what we're talking about today, but hazard mitigation, transportation engineering, transportation planning, you name it. And with that, it's really put us in a unique position to also talk about why geospatial data is critical. And so from that, I want to dive into the topic of the conversation here today. And obviously, I know that's a very brief introduction to Ecopia, but for me, the goal of today is not necessarily to talk about us, and more talk about the value of data and how that can be critical for your organizations. So what is the problem? Why are we suddenly talking, on the mainstream about climate resiliency, and why are we talking about the integration of data efforts? Well, there's two aspects. I think, first of all, these situations and the events that we're experiencing today are becoming more frequent in terms of natural disasters. Likewise, the news is picking up on that, and the information that's being circulated is bringing more attention to it. But the second piece of that is that attention has drawn and brought to the table additional investments. And when I say investments, I'm effectively talking about the billions of dollars that are being allocated by the federal government to dealing with these problems that we're facing. And what are these problems? So I've obviously simplified this, because if we really talk about the problems that are related to the climate, we'd be here for a very long time. But I'm going to focus on a few that I think resonate most and speak to where geospatial data fits into this mix, this kind of theme. So when we talk about flooding, I'm not just talking about the effects of coastlines and talking about storm surges. I'm talking about pluvial and fluvial risks. I'm talking about inland properties. We're talking about the experiences of increased rainfall, and how essentially communities are increasingly becoming more at risk. And a lot of that, especially coastal communities, is based on changing landscapes. A concrete example of that would be, in Florida, we're seeing the devastation. We saw the devastation that happened last year. And a lot of that would have been mitigated previously in terms of mangroves and natural vegetation that limited the effect on those coastal communities. But with the changing landscape, with growing urbanization, what we're seeing is a greater risk to communities. The problem is we're having a very hard time understanding and quantifying what that risk is. And without having a reliable source of truth and data, it's very difficult to do. So what we wanted to do is, let's break this down into something that makes a little bit more tangible sense. And so we did a brief little study using Ecopia did a brief little study, and we looked at what is the coastal threat, what is the immediate threat in terms of the exposure to the population. And essentially what we did is a very simple solution, in the sense that we looked at a 1 mile buffer around the United States in terms of those coastal communities. And we tried to understand, how many people were at risk. And obviously it's very difficult to put together a robust methodology for this, but sometimes simple is better than anything else. And what we found is essentially within that 1 mile buffer, not only is there nearly 8 million structures, but it's also some of the largest metros in the United States: LA, Chicago, Miami, Houston, San Diego, even the downtown core of New York, Manhattan. And so it's safe to say that when we talk about the risks to these coastal communities, it is very significant. It is very significant on life, and it's something that needs to be taken into consideration. But also we need to understand how significant the problem is in order to design a true risk mitigation strategy. The second one is wildfires. I think this is something that probably likely everyone on this call has experienced the effects of this year. And that's not to say necessarily a wildfire affecting your direct community, but also what we're seeing is the effect of wildfires and air quality as it's resonating across North America. So the photo that you're seeing on the right there is actually taken just a couple of months ago, and that's in downtown New York, right in the middle of Manhattan. And so it gives you an idea just of the impact of what we're seeing. And you can directly see the correlation that ultimately, yes, you're talking about the factor in terms of the human element, but there's also very much a monetary aspect to this. We're seeing increasing volume of fires and also increasing devastation associated to that. But it's once again another thing that it's very difficult to quantify and qualify which communities are most at risk of these events. How do we understand where the problem is? The next one, and the one that I'm actually going to spend quite a bit of time focusing on today, is extreme heat and urban heat islands. And this is actually one that's often overlooked, but what is a pretty, to me, revealing factor of how critical this is extreme heat is the #1 cause of weather-related deaths in the United States. This defeats anything in terms of hurricanes, tornadoes, natural disasters. So it's a pretty darn big problem. And it's something that, yes, people are talking about now, but when we look at the communities that are most affected by this, it's often in areas where there isn't enough data to be able to quantify the real value or the real risk associated to this. And this is speaking to the piece of data equity. And this is something that we're we're going to look at. And I actually have a case study I'm going to show you guys towards the end of this presentation that does a really good job of articulating exactly how significant of a problem this is, and more importantly, how geospatial data fits into that mix. So with that, a good segue. So what is the solution to these problems? Obviously, there's no silver bullet here. These are some of the greatest problems that we're facing today, and it requires very complex problems and, more importantly, collaboration to be able to address and mitigate. So what we're doing is providing a starting point. And to me, that is what geospatial data is. It's essentially providing that foundation. And that foundation is driving into a climate resiliency strategy. And being an AI company, I'd like to leverage similar technologies. And ChatGPT came into mind here and did a wonderful job of helping me out in defining, what actually is a climate resiliency strategy. And I'm not usually one to read off slides, but I'm going to take direct correlation from this and just read this out loud, because I think it does a very good job of just framing the narrative of what we're trying to achieve here. So a climate resiliency strategy refers to a comprehensive and integrated set of actions, policies, and measures designed to help individuals, communities, and ecosystems adapt and withstand the impacts of climate change. It involves proactive planning, risk assessment, and management aimed at enhancing the capacity of natural and human systems to cope with changing climate conditions. Honestly, I think I could have worked on this statement for a week and never have come up with something as accurate as that. But the takeaway from this for me is the collaborative tone of natural and human systems. And ultimately, I think that is the one thing that we need to take into consideration more. When we're looking at the impact of climate change on communities, resiliency is not just about understanding the natural landscape. It's about understanding how the human and natural world can evolve together and how we can develop solutions moving forward to effectively put in transitional resiliency. And ultimately, that is where I see geospatial data being such a critical aspect of it. And with that comes innovation. And innovation is critical to climate resiliency because status quo is what essentially has got us to where we are today. And that is where I'm focused on leveraging the power of information. So geospatial data, the line that I always like to say is the foundation of innovation. In this case, it's the foundation of a climate resiliency strategy. As I noted previously, they talk about risk planning and mitigation, but how do you understand risk without understanding the environment today? How do you understand where to expend resources if you don't have a good understanding of what is happening in the world or your environments today? Yes, there's open source information. Yes, we're reliant on data aggregation, but if we're spending billions of dollars to mitigate situations, don't you think it's worthwhile to look at things a little bit more closely and understand our environments and be certain of these elements? And that is where I feel like geospatial data is plays a critical role, but it also needs for individuals and stakeholders to step up and engage with the community and be able to create these data sets and make sure they're maintained sustainably so that we can effectively integrate these workflows. So when I'm talking about geospatial data sets, I'm talking about understanding these environments. It's about impervious surface analysis, natural environments, looking at your existing infrastructure in both your urban settings and rural settings, making sure that data is not only accessible in those communities that historically have access to a lot of resources, generally speaking, being financially, but also communities that historically haven't had the capacity to create these data sets. It's kind of a lost lead situation where oftentimes we're leveraging these data sets and aggregating information, like I said, but we're only collecting information that has been created by those communities that have the resources. And so we're putting in place programs based on data sets that are in themselves already catered to the communities that have likewise probably the least amount of risk mitigation needed. So what geospatial data, how does geospatial data fit into the mix? So geospatial data is essential to developing and implementing a climate resiliency strategy. I hope that's become clear here. It provides important information on the location, extent, and vulnerability of natural and human systems and helps identify areas and populations that are most at risk from climate change. It tells us the story of the what and the where. And more importantly, it paints a picture that can be understood by people who may not necessarily understand the full picture of a climate resiliency or the impacts of it. But taking that into consideration, it's about also layering in multiple pieces of information. One set of geospatial data, whether it's land cover data or maybe climate data or demographic data, all of those elements by themselves hold very little value. But when you start bringing that information together and you start leveraging these sources of information to paint a picture, that's where you build and drive a really unique narrative. To the point that I'm actually going to show you guys a sample and a case study that we did where we started integrating this. One of my biggest problems as being a geospatial data company is that we always talk to people about what our data can do. And I wanted to say, okay, let's actually show it. And that's going to be something that I'm going to do here in about 10 minutes or so when we get to that point of the presentation. But first, I do want to talk a little bit about, breaking it down into our side. Where does Ecopia fit into this mix? How are we working with our clients already to support their elements? So the first is when we look at the 2D based foundational layers. 2D based foundational layers are essential in just understanding the most basic requirements. We're understanding transportation routing, looking at roads. We're looking at where buildings are, address data sets, understanding the location of people. We're looking at open water bodies, understanding if you're looking at flood modeling, and we're looking at not just water runoff that could affect the communities, but also your natural environments. How is water runoff and pollutants being flowed into these natural water bodies? All of these elements are critical in terms of building and establishing a climate resiliency program. The next stage is taking it and looking at it from a three-dimensional perspective. So the one thing I want to highlight from this picture is actually the bridges. And bridges, ironically, as they relate to this, are historically developed in a 2D fashion, meaning they lack that Z coordination that is critical, especially from a flood modeling perspective. So we've actually been working with, to provide a concrete example, in Austin, Texas, and essentially what happened was during Hurricane Harvey is they didn't have a proper asset inventory of their bridges in the sense of understanding whether or not they would be underwater during flooding scenarios. And in fact, what they were doing is routing people in locations where those bridges were underwater, where we are seeing that the elevation data not correspond to the actual level of height of the bridges. And in fact, you'd have 18 to 24 inches of water runoff, and that's enough to essentially push a car off. So having access to this information could be truly life-saving. The last piece, which I argue is probably the most important, is change detection. The value of geospatial data and the value of building any sort of strategy, it's great to have one set of information. It's great to understand whether it's environment today or environment of yesterday, but being able to understand how environments change and how they work together, and how, for example, even if you're looking at the integration of your climate resiliency strategy, where you're actually making those investments, you want to be able to map out those changes. And the example that I'm illustrating here is relatively small in terms of identification of those new structures versus a removed structure. And the reason why we're doing this instead of saying a community that has a massive change is because change often isn't massive. But if you miss these small changes, they compound pretty darn quick. And if you're not quantifying that change on a year-over-year basis, you're going to run into the situation that it's very difficult to qualify or even quantify the investments that you've made in terms of your mitigation strategies. And this is where that element comes into play of, when we look at geospatial data strategies, historically, it's been based off of project-based solutions. You're looking at, hey, you need a roadway data set for this one project, or you're looking at a community development and you need to understand, the natural landscape. Or, for example, you're looking at the impact of a solar field and the water runoff on one community. But we need to change that narrative and understand that the use cases are obviously broad. And having that comprehensive layer in a way that can be accessible across, whether we're talking about a community, a state, or a county, or even the federal organizations, having access to one comprehensive data set is critical in terms of maintaining the sustainability of these programs and the sustainability of a climate initiative. So moving on from this, the next element is, how does this all come together? And there's 6 primary points where a geospatial data strategy fits into place. Those are risk assessment, vulnerability mapping, land use planning and management, infrastructure planning and design, emergency response and preparedness, natural resource. Oh, sorry about that. I think we had someone else that was on a mute. And lastly, community engagement and awareness. Now, why am I taking a little bit of time to read through these? Because ultimately, these are the elements that are critical when you look at funding applications. And as I said at the start of this, why is climate resiliency strategies becoming such a topic of interest? Well, that's for a variety of reasons, but at the end of the day, without resources to enact a strategy, it's not really good to just talk about it. And so for us, I want to be able to help you understand how geospatial data fits into these elements, and more importantly, how you can articulate yourself and how you can articulate the value of geospatial data within these funding applications and these keywords, so to say. So risk assessment and vulnerability mapping. This one to me is fairly straightforward. Land cover data can help you identify areas that are susceptible to natural hazards, whether you're looking at flooding, urban heat islands, wildfires. And relatively speaking, a government can develop an effective disaster risk reduction strategies that prioritize those vulnerable communities based on just that basic 2D foundational information. So when we look at those elements a little bit more deeply, the first one would be flooding. So let's talk about excessive runoff and potential flood risks. You're talking about retrofitting of green infrastructure. Perhaps it has to do with permeable pavement, identification of green roofs, rain gardens. Maybe you're looking at hydrological characteristics, the integration of land cover two-dimensional data with, for example, the 3D hydrology program. And we're working with the state of Washington right now, and what they found is integrating those two layers together is critical for them to understand the hydrological models within the state. Other things like monitoring changes in pervious surfaces over time. We work very closely with the city of Detroit, and on average, we're doing a change detection for them every year, but on average, what they're finding is that the impervious surfaces in the city are changing at a rate of about 2% every single year. So 2% doesn't sound like too much, but once you start, if you start looking at that over a period of 3 years, if you don't understand where those changes are taking place, you're really missing out on a lot of critical information. Wildfires, when we talk about, the assessing information in terms of distribution of vegetation in given areas, we're looking at understanding layers of forest, grassland, shrubs, or looking at how those elements are influencing the fire behavior and spread potential. Having access to a true tree canopy layer that is up to date is critical to those elements. One of the things that's really a bit mind-boggling to me is how many fire institutions are reliant on open source data and open source information for their strategy programs. I'm not necessarily going to be naming any names here, but some of the largest fire institutions in the United States are still reliant on data aggregations from open sources that they cannot guarantee the accuracy of. Meaning, if we look at a building footprint data set, they don't necessarily know if that structure is still there, or if they're missing structures that were built in the last 5 years. To me, these are the most basic principles of information that should be critical to these programs that are already spending millions, if not even billions of dollars in terms of their mitigation and response strategies. The last one is urban heat. And assess, identify, integrate, monitor. I don't want to dive too much into this yet, because this is what our whole case study is about. And I want to be conscious of time to make sure we have enough to dive into this. But this is one that I think we'll paint a pretty good picture for. Land use planning, essentially, we break it down into three elements: land suitability, zoning regulations, and environmental considerations. So this is about looking at, for example, things like topography, soil characteristics, hydrology, vegetation, essentially determining the most appropriate land uses that align with climate resiliency strategies and goals. And this is about making sure that you have a clear understanding in the sense of that digital information to evaluate community development. And I think that flows through in terms of the three of these elements, from land suitability, zoning, and environmental considerations. Environmental considerations, one thing that's often overlooked is, some of the strategies that we put in place for climate resiliency may also have a net negative impact. There's a really compelling study that was done in the state of Massachusetts, where they looked at the impact of solar panel fields and whether the impervious runoff that was created from those was creating more problems than the environmental considerations that were adopted from just their normal energy policy. So you know, in trying to do something good, maybe, for example, that may have the complete opposite impact. Infrastructure planning and design. I don't want to spend too much time on this because I think it flows directly into what I just talked about. But ultimately, we break it down into, you know, 4 critical pieces: vulnerable infrastructure, infrastructure risks, land use planning, and scenario modeling. For me, the number one aspect of this is alignment to the communities that historically would not have reliable information for planning. And vulnerable infrastructure, generally speaking, correlates with vulnerable communities. So if we can leverage geospatial data to help identify those communities, there's a pretty large correlation and a large chance that what you're going to find is vulnerable infrastructure exists within there as well. You know, a concrete example of that is if you look at post-disaster scenarios in terms of hurricanes, it's not generally the communities that have a higher medium income that are most affected. It's oftentimes those with lower income scenarios that are ones that are flooded most, that are in situation where all of their existing infrastructure is destroyed. That's not coincidence. Emergency response and preparedness. I talked about this a bit earlier, but essentially this is the concept of understanding your existing assets and making sure that they're optimized to be leveraged in those scenarios where time is critical. So evacuation routing, resource allocation, logistics, post-disaster damage assessment and recovery. This is about having that data before a disaster happens, in a sense of understanding that environment of today so that you can deal with the situations that happen, but also even the post-disaster element. How can you quickly identify where where communities are affected most? And if you don't have a baseline of data, how are you supposed to know? And yes, imagery is a compelling resource here. You know, oftentimes, even if we look at what's happening in Maui, Hawaii right now, a lot of what's being released is those imagery data sets. And yes, it provides a great visual representation. But from a planning perspective, without the data, it's very difficult to put in place actionable strategy and actionable resources to deal with those situations without the actual backline data. Natural resources management. This is kind of grouped into 4 categories, and I'm going to skip through this a little bit just for the sake of time. But essentially what we're talking about is monitoring the change in ecosystem and habitats, forest management, looking at just the general environments of forests, but also carbon sequestration, marine and coastal resource management, and lastly, habitat suitability modeling. There's a lot here, and I fully recognize that this would, once again, this slide, in my opinion, you could spend an entire day just talking about this. But my goal here is to highlight the use cases. My goal here is to talk about where data, being geospatial data, fits into the mix with climate resiliency strategies. And to cap that off, essentially comes the piece that I think is, arguably speaking, where we're missing out most on: community engagement and awareness. If you even look at how the news picks up on these stories, or, you know, we talk about the impacts of climate change, and that's all fantastic to talk about it. But I think as an industry, we have a responsibility to do a better job of communicating the risks. We have to do a better job of evaluating the risks, and we have to do a better job of informing people of what is being done and what is being enacted and why it's being done. And historically, this is lacked. So for me, geospatial data presents a very compelling visual story, whether you're looking at change detection within communities, 3D modeling scenarios, and looking at flood runoff. Ultimately here, this enables an interactive platform that can enable users to access relevant information about their own communities. You're facilitating engagement and awareness. And ultimately, when you get buy-in from your constituents, that's when you start to establish a very sustainable climate resiliency strategy. So how do you convey these stories? How do you make this narrative compelling in a way that resonates with your local, people within your communities who maybe have zero understanding of how this works? So what I want to do is I'm going to take a little break from PowerPoint here, and I'm going to talk you guys through a little bit of a story or case study, I should say, that we did. And essentially, like I said here, I don't want to just talk about how you can use geospatial data. I want to actually show you and demonstrate the value of that. So what we did is we did a climate resilience study, specifically looking at urban heat mapping and inequality in the greater Houston area. So these are all pieces that we talked about here: building community resilience, changing climate perils. This is the backbone of the presentation that I just gave, in the sense that we all know the why. We understand why we're in this conversation today, but what are we doing about it? And this is where we wanted to look at a community that was diverse. We wanted to look at a community that really had exposures to different races, different incomes, but also a varying natural landscape. Someone that had exposure to, both those coastal elements, but also inland. And essentially, Houston presents a really good test case for that. So what we looked at was an area of about just over 12,000 square miles, so pretty significant area. And from that, we leveraged our existing land cover data sets to look at the disparities between impervious surfaces and tree canopy coverage. More importantly, we said, as I said to you earlier, the value of geospatial data is when you start looking at multiple layers of information. And so what we did is we aggregated that information into the census, into 4,400 census blocks. So this is information that's publicly available. And what we wanted to understand is, where communities had greater levels of impervious surfaces versus which communities had greater levels of vegetation. And there's two fronts to that. One, communities that have direct percentage of higher impervious surfaces are obviously more at risk to urban heat. Likewise, communities with greater impervious are also more at risk to flooding. On the converse side, what you see is communities with greater vegetation, those are going to be cooler. Those are going to be less exposed to the risks. You're going to have, a phrase that's been talked about recently a lot within these communities is the sponge effect. And the communities that have more vegetation are, generally speaking, going to have a higher sponge effect because they're going to be able to absorb a lot more water runoff. And so these are just the visuals. This is giving you the census block that's talking about percentage of impervious versus percentage tree canopy. I think that's fairly straightforward. Pretty much this paints a picture. This is giving you a piece of information that would enable anyone to understand. So what happens when you look at the relationship between income and impervious surface levels? So not only did we group it into those census blocks, but what do those census blocks mean? And when we look at that data, essentially what you find is the bottom 20th percentile in terms of median income have an average of 48% impervious land cover within those census blocks. Conversely, when you look at the top 20%, that's down to 36%. Doesn't necessarily paint enough of a picture to me. So you got to dive a little bit deeper. And so when you look at these communities, what we wanted to say is, okay, let's take that and actually quantify it. So for example, what we see in here is this community here. Obviously you can see that census block. It is a high median household income, 152,000. That is certainly a relatively high, especially in the scope of the United States. What we're seeing, percentage impervious 54, percentage tree canopy 32%. So yes, a lot of impervious, but conversely, a ton of tree canopy. Now, just a few blocks over, you look at this census block, what you're seeing is 2/3 of the population lives below the poverty line. Median household income, 27,000. Percentage impervious, 82%. Percentage tree canopy, 6%. And if that doesn't paint a picture of just demonstrating which communities are going to be most at risk, I don't know what does. And how did we do this? Well, like I said, essentially it's taking geospatial layers and aggregating that information in a way that can be compartmentalized. So this is where you take the impervious surface data sets, and all of this stems from our land cover data sets. So you can even take this a step further. You can look at the structures, you can look at what kind of canopy, you can look at what kind of vegetation is within those communities. But without having this strong, foundation, you don't have the tools to be able to develop a study like this. And this is a similar scenario here that you could literally paint the exact same picture with, exact same community. You can see the study in terms of the tree canopy and just those dots to be able to illustrate that. So any community, in theory, that we have data, we can do this for. And how does, I always like to bring up, okay, what do you do with this? Well, ultimately speaking, there's some direct funds that tie into this. You look at tree equity. Well, there's $1 billion of federal funding available to increase equitable access to trees and green space in underserved urban areas. So that's a direct resources that is available, but needs to be validated in order to get access to those funds. And so as a company, yes, we're here as a business. Yes, we're here to talk about data, but I find it very important for us to also say what this data can do. And that's why essentially we're also going to be doing similar studies in every single state for every single major metro. And hopefully that information can be used as a tool for some of you on this call to be able to validate and support getting access to more resources for your community. So let me just get back to this, because ultimately that is my presentation. So I hope I was able to give you guys a little bit more information on Ecopia. I could provide a little bit of credibility to what we're doing and where we're going. But most importantly, I hope you were able to take away something from this to be able to validate the need for geospatial data and how that can fit into developing a really comprehensive climate resiliency strategy. And more importantly, I hope it demonstrated that the work we're doing today is very important. And I appreciate all of you being here today to be engaged with this conversation. And I welcome any more questions that we have here today. Likewise, if there's anything else you'd like to talk about more privately, I can certainly make myself available. Likewise, Justin can be available to help field some of those questions. But I'll open it up now in terms of, we have about 10 or 15 minutes. If we have any questions in here, I see some stuff in the chat. Justin, is there anything? Oh, no, I don't see any questions in the chat box yet. Oh, okay, Max has asked us a question to start off. Thank you for kicking things off, Max. So how are your data sets accessed, and what is the cost structure for using the various data sets? So the first thing I want to say, Max, is we have multiple layers in terms of data licensing. However, if we look at what we're doing in terms of what's immediately accessible for communities at no cost, NOAA and the CCAP program are releasing 1.3 million square miles of our land cover data set for coastal communities across the US. That will be an impervious tree canopy, shrub, and open water data set that will be available free for use. And that will be distributed in the next 4 to 6 weeks in terms of all coastal states in the US plus Alaska. So we're really excited about that. Now, taking steps a little bit further, if you're interested in getting access to additional high resolution vector data sets, we'd be more than happy to talk with you directly about how that data can be accessed and what we can, yeah, exactly. You're in San Diego, you'll get access to really, really great information. But if you're interested in those higher resolution vector data sets, we'd be more than happy to talk you through how that can be accessed, whether it's government side or private side. There's opportunities that can be made available. Next question. Example in Houston. Did you collect maximum water elevation flooding during last hurricane? Great question. Ultimately, we did not collect any information on those flooding pieces. However, we are taking that case study a step further, and we are in the middle of trying to collect that information to integrate it into the model and start to demonstrate in a way that specifically we want to be able to, as I talked about, demonstrate that it's often the lower income communities that are going to be most affected during those scenarios. And we know for a fact that was the case, but correlating all of that information together does a really good job of demonstrating it in a way that, hey, we knew this ahead of time. Why didn't we prepare for it? So to answer your question, we have not done it yet, but we are certainly planning to do that. And actually right now we're working with Texas Water Development Board to get access to some of that information to be able to support an enhanced case study there. Any other questions? If you want to, you're also more than welcome to take yourself off mute and talk. Promise I'm friendly conversationalist. All right. I don't see any more questions. So I guess we can cap it off here, Karen. But I'll finish off just to say if there are any things that you want to talk about more on a one-on-one basis instead of an open forum, please don't hesitate to reach out. My contact information is on the screen. And yeah, I really appreciate you all taking the time out of your day to join us. And I hope this was a time well spent for you guys. And I hope that you were able to take away something from this presentation, whatever that may be.
Thank you so much, Brandon and Justin. We were really happy to have you. It was a great turnout and a great topic. So I'm glad you're sharing your contact information, and feel free to reach out to Brandon if you have any questions. And again, our call for abstracts for the national conference will be posted next week on our website. We'll be sending that out, and we hope to see you all in Kansas City, but I'm sure we'll see you at the next Lunch and Learn before that. Thanks so much, everyone, and have a great day.
Thank you.
Bye.